So in this lecture we will discuss application of residue integration, uh, type 2 real integrals, type 2 problem. Okay, so that is integral minus infinity. If you want to calculate integral minus infinity to infinity f of x dx, then that must be equal to 2 pi I integral sum of residues of f of z, where the singularities are residue of the singularities in the upper half plane. Okay. So the assumptions, our function f of x must be a real function, real rational function whose denominator is at least 2 units higher than the degree of numerator. For example, I will give you an example. If f of x is of the form 1 by 1 plus x square. Here, what is the degree of numerator? Numerator degree in the, it's 1, right? It's a constant. So what is the numerator's degree? 0, right? That means x raised to 0. 1 into x raised to 0. So degree of numerator is 0. And what is degree of denominator? Anybody? എന്താണ് ഡിനോമിനേറ്ററിന്റെ degree? 2, right? 2. So numerator has degree 0 and denominator degree 2. Therefore, the first condition is satisfied. And for second condition, if f of x is a real function, then we will write f of z. Instead of x, I am writing z. 1 plus z square. Now what are the singularities here? This can be written as z minus I into z plus I. The singularities are z is equal to plus or minus I, and you know that these are pole of order 1. And okay, so the second condition is f of z must have only finitely many poles. So this condition is also satisfied. And the one of the important thing is our contour is this semicircle in the upper half plane. This is our contour. So we will take only singularities in the upper half plane. That is here I. So we will not consider any singularity in the lower half plane. So we will only consider singularities in the upper half plane. അപ്പോൾ ഇവിടെ upper half planeലുള്ള singularity ഏത് മാത്രമേ ഉള്ളൂ? ഏത് സിംഗുലാരിറ്റി ആണ് അപ്പർ ഹാഫ് പ്ലെയിനിലുള്ളത്? അപ്പർ ഹാഫ് പ്ലെയിൻ മീൻസ് quadrant 1 and 2. So I is the only singularity in the upper half plane. Okay. Then we know that then we can easily find integral minus infinity to infinity 1 by 1 plus x square dx. This is simply equal to 2 pi I into residue of singularities in the upper half plane. That is residue of z equal to I f of z. So that is the integration will be very easy, because the only thing we have to do is we have to find the residue at f of z at singularities in the upper half plane. So now we will do an important problem. Show that first problem. Show that integral 0 to infinity 1 by 1 plus x square dx is equal to pi by 2 root 2. Pi by 2 root. Okay. So write down this question. Integral 0 to infinity 1 by 1 plus x raised to 4 dx is equal to pi by 2 root 2. So from the above result we know that Okay, now check what is this degree of numerator here. So here f of x is, we have f of x is 1 by 1 plus x raised to 4. Tell me what is numerator's degree?
0.
0. And denominator degree?
4.
4. So that is 2 times greater than, at least 2 times greater than the degree of numerator. Therefore, we can use the result. So we know that integral minus infinity to infinity f of x dx is equal to 2 pi I into sum of residues of f of z, and this residues is in the upper half plane. Okay. Okay. So but there is a problem here, because here our integral is from minus infinity to infinity, but we have to do here the integration is from 0 to infinity. So now let us take this f of x. F of x is of the form 1 by 1 plus x raised to 4. Is f of x is even? We know that what is f of minus x? 1 by 1 plus minus x all raised to 4, all raised to 4, which is equal to 1 by 1 plus x raised to 4, which is equal to f of x. So what we got? We got f of minus x is equal to f of x. Therefore, this is an even function, right? So we know that integral minus infinity to infinity f of x dx, if f of x is even function, this is equal to 2 times integral 0 to infinity f of x dx, right? So which implies integral 0 to infinity f of x dx is equal to 2 times 1 by 2 times integral minus infinity to infinity f of x dx, and we know that this is equal to 1 by 2 times, we will use this result, 2 pi I into sum of residues. Now our aim is we have to find out the residue. So first of all, we have f of x is equal to 1 by 1 plus x raised to 4. Then what is f of z? 1 by 1 plus z raised to 4. Now we want to find out the poles or singularity. So that is very important step. So here f of z is analytic everywhere, everywhere except at the points, at the points where z raised to 4 plus 1 is equal to 0, which implies all the points where z equal to minus 1 raised to 1 by 4, minus 1 raised to 1 by 4. So now we want to find the singularity. So how many roots are there? 4. So we want to find out fourth root of minus 1. So I will give you a formula for finding nth root. You note it down, formula. Hmm. If z equal to a raised to 1 by n, then how to find out values of a raised to 1 by n? Then that means z raised to 4 plus a raised to 4 is equal to 0. Then z equal to z, sorry, z raised to n in plus a, z raised to n plus a equal to 0. Then z equal to a raised to 1 by n minus a raised to 1 by n, sorry, z equal to a raised to 1 by n into cos theta plus 2k pi divided by n plus I tan sin theta plus 2k pi divided by n, where k ranges from 0, 1, 2, etc. up to n minus 1. So this is the formula. Note it down, that formula. If you want to find n, that is z equal to a raised to 1 by n, the formula is z equal to a raised to 1 by n cos theta plus 2k pi divided by n plus I sin theta plus 2k pi by. So theta is, we have to calculate this. This is in polar form. So here we have z equal to minus 1 raised to 1 by 4. We want to. So the minus 1 is here, right? Minus 1 is here. Then the polar form of minus 1 is equal to polar form 1 into e raised to r is 1, right? E raised to, and what is this angle? This angle is pi I. So minus 1 is pi I. So z equal to e raised to I pi all raised to 1 by 4. So this we want to calculate. We will use this formula. So a is equal to 1 here. Therefore, we will find the singularity. Z raised to 4 plus 1 is equal to 0. Therefore, z is equal to 1 raised to 1 by 4 into cos theta is pi here. Cos pi plus 2k pi divided by 4 plus I tan sin pi plus 2k pi divided by 4, and here n is 4, therefore k equal to 0, 1, 2, 3. Okay. So we will get 4. Now we will find out those roots. So this f of z is not analytic at z is equal to, first I will put k equal to 0, then you will get cos pi by 4 plus I sin pi by 4. If I put k equal to 0 in this equation number 1, then I will get this. And next point of singularity is I will put k equal to 1. If I put k equal to 1 here, cos pi plus 2 pi, that is 3 pi by 4 plus I sin 3 pi by 4. Similarly, z equal to cos k equal to 2, 6 or 5. 5 pi by 4 plus I sin 5 pi by 4. And last, k equal to 3 cos 7 pi by 4 plus I sin 7 pi by 4. If you have any doubt, you can ask. So these are the poles, simple poles. Now we want to check which of the following are in the upper half plane. So we will only consider those poles in the upper half plane. So this is our C. So when is the points in upper half plane, z equal to x plus iy. So upper half plane means it in the first quadrant. That means imaginary part is positive, then the points in the upper half plane. If imaginary part is negative, then this will be in the lower half plane. So we want to check for what values. So we want to check for what values imaginary part is less than 0. So So now first I will check. So I will use a calculator. You can use calculator. So first we will check is what is the imaginary part of first point, cos pi by 4, cos pi by 4, and this imaginary part is sin pi by 4. Now we want to check whether sin pi by 4 is, I'm using this calculator, sin pi by 4, the value is this 7 point, this value 0 0.7071, etc. That means this is a positive value. So positive value means this this quantity must be inside upper on the upper half plane. Okay, this quantity is in upper. Now we want to check whether this quantity is positive. So let's say no 3 5 5 5 5 pi 5 pi by 4. So sorry, first second is 3 pi by 4, right? 3 pi by 4. So the 3 pi by 4 also value is 0.701. That is also positive, right? Here 3 pi by 4 is also positive. Therefore, this is also in the upper half plane. Now you check what will happen in this. And then I'm just calculating this. 5. 5 pi by 4 is minus. Look at this, minus 0.700. So this will be in lower half plane. So this will, we will not consider this. So this is not, and I will check the other 7 pi by 4. That is also 7 pi by 4 is also negative, right? Negative 0.707. So that quantity is also in the lower half plane. So the only points of singularities or poles in the upper half plane is this, this f of z is equal to 1 by 1 plus z raised to 4 as singularity, as poles in the upper half plane where they are z equal to, we have 2 points, right? Cos pi by 4 plus I sin pi by 4 and z equal to cos 3 pi by 4 plus I sin 3 pi by 4. This we have we have we have to calculate integral 0 to infinity 1 by 1 plus x raised to 4 dx, which is equal to 1 by 2 times 2 pi I residue of z equal to cos pi by 4 plus I sin pi by 4 1 by 1 plus z raised to 4 plus residue of z equal to cos 3 pi by 4 plus I sin 3 pi by 4 1 by 1 plus z raised to 4. Okay. So is it clear? So now our aim is to find out the residue of these two quantities. So the first one is residue of Z equal to our singularity is cos pi by 4 plus I sin pi by 4 of 1 by 1 plus z raised to 4. Okay, here we know that the poles are simple. So, and this is of the form P of z divided by Q of z, and P of z is 1 and Q of z is 1 plus z raised to 4. Now we check what is P of z is 1 and Q of z is 6. What is P of cos pi by 4 plus I sin pi by 4? This is equal to P of z is 1, always 1, not equal to 0. And what is Q of cos pi by 4 plus I sin pi by 4? This is a root of this polynomial, therefore this is equal to 0. So our condition is satisfied. And Q dash of z, this is equal to, we know that Q dash of z is 4z cube, and Q dash of cos pi by 4 plus I sin pi by 4 equal to 4 times cos pi by 4 plus I sin pi by 4 all cube. And we know that what is cos, we have a result. D movies result, you know. Cos theta plus I sin theta all raised to n is equal to cos n theta plus I sin n theta. This we know. So what is here? This is equal to 4 into cos pi by 4 all cube, that is cos 3 pi by 4 plus I sin 3 pi by 4. So thus, therefore, I will erase this. Therefore, this result is P of cos pi by 4 plus I sin pi by 4 divided by Q dash of cos pi by 4 plus I sin pi by 4. This is equal to 1 by 4 into cos 3 pi by 4 plus I sin 3 pi by 4. Okay, so this is clear. Now this you can written as 1 by 4 times 1 by e raised cos theta plus I sin theta is e raised to I theta. So I times 3 pi by 4, which is equal to 1 by 4 times e raised to minus I 3 pi by 4. Similarly, what is residue of z equal to cos 3 pi by 4 plus I sin 3 pi by 4? 1 by 1 plus z raised to 4. This is simply equal to same P of cos 3 pi by 4 plus I sin 3 pi by 4 divided by Q dash of cos 3 pi by 4 plus I sin 3 pi by 4 is equal to P is always 1 by Q dash 4 into cos 3 pi by 4 plus 3 by 4 all raised to, so this is equal to 1 by 4 times cos 9 pi by 4 plus I sin 9 pi by 4, which is simply equal to 1 by 4 times cos 9 pi by 4 minus I sin 9 pi by 4. So this is the residue. So we got both residues. Therefore, integral, okay, we already this integral. So this integral 0 to infinity 1 by 1 plus x square is 1 by 2 times 2 pi I, the sum of the residues. So I will write here. So therefore integral 0 to infinity 1 by 1 plus x raised to 4 dx is equal to 1 by 2 times. Why this is 1 by 2? Because this is an even function and it's integral from 0 to infinity. So 2 pi I, sum of the residues are 1 by 4 times cos. First residue is cos 3 pi by 4 minus I sin 3 pi by 4 plus 1 by 4 times cos 9 pi by 4 minus I sin 9 pi by 4. This is equal to pi I divided by 4 cos 3 pi by 4 minus I sin 3 pi by 4 plus cos 9 pi by 4 minus I sin 9 pi by 4. Now we will calculate this pi I by 4 cos 3 pi by 4. Cos 3 pi by 4 you can written as cos pi minus pi by 4, right? That is cos pi minus pi by 4. This is equal to minus cos pi by 4. This is equal to minus 1 by root 2. So minus 1 by root 2 minus, similarly this we will get minus I by root 2 minus 1 by root 2 plus cos 9 pi by 4. This is equal to cos 2 pi, 2 pi plus pi by 4. Cos 2 pi plus pi by 4 is cos pi by 4, which is equal to 1 by root 2. Similarly you can write sin, that is 1 by root 2 minus sin 9 pi by 4 is minus I by root 2. So this and this get cancelled. So you will get pi I divided by 4 into minus, if you add both, minus 2I divided by root 2. So 2 and 2 get cancelled. You will get I and I, minus 1 into 1, 1. So pi by, you will get pi by 2 root 2. So the answer is integral 0 to infinity 1 by 1 plus x raised to 4 is pi by root 2. So we got the answer. So we got answer. So this is what we have to calculate. So we got the answer.